Students, in this video we will discuss the chemical bonding part 2, that is electronic theory of valence. Under this we will discuss ionic bond, and this is given by the scientist Cosell. So the continuation of the former video. Okay, so this in the formation of ionic bond, dissimilar atoms participates. That means two dissimilar atoms like sodium and chlorine. Okay, the atom with more electropositive character like metals transfer electrons to more electronegative character non-metals, okay, like chlorine. And the electronegativity between these two dissimilar atoms, maybe sodium, chlorine, two dissimilar atoms, right? So electronegativity difference must be greater than 1.9. Then only ionic bond formation takes place. Okay, so always an ionic bond forms between two dissimilar atoms, and by the transfer of electrons. Always an ionic bond forms between two dissimilar atoms by the transfer of electrons like sodium and chlorine. And the ionic bond is always formed between the highly reactive metals which are on the left side of the periodic table. Okay, example 1A and 2A, with highly reactive non-metals which are on the right side of the periodic table, example 6th and 7th. So ionic bond is formed between highly reactive metals and highly reactive non-metals. That means between 1A, 2A, etc. and between 7A and 8A. Leftmost elements and rightmost elements participate to give ionic bond. Okay, then so what metals do? Okay, what electropositive metals do for the formation of ionic bond, that we have to see. Metals which are electropositivity in character always lose electrons to attain octet or stable electronic configuration and forms cations. Listen carefully. Metals which have electropositivity character always lose electrons to get octet stable electronic configuration and forms cations. See one example here. Sodium, okay, with the 281, that means in the outermost shell 1 electron, loses 1 electron to get Na plus cation with 2,8, that means outermost shell has 8 octet configuration. So always sodium or 1A or 2nd A group, 3rd A group elements loses electrons to form cations. Okay, in the same way, metals which have more electronegativity always gain electrons to get octet stable configuration and forms anion. See one example here. Chlorine accepts with the 287 configuration. It needs one more electron to get octet configuration. So chlorine gains one electron to form chloride ion with the last shell octet configuration. So this is anion. Here it is. So non-metals form anions. Non-metals form anions. Metals form cations like Na plus. Non-metals form anions like Cl minus. So two opposite charges are formed. Then electrostatic force of attraction between the positively charged cation and the negatively charged anion leads to a bond called ionic bond or electrostatic bond or electrovalent bond. Always electrostatic force of attraction between positively charged cations like Na plus and negatively charged cations, anions like Cl minus, forms a bond, ionic bond, or it is also called as electrovalent bond or electrostatic bond. Here the transfer of electron takes place from cation to anion, from metals to non-metals. Okay, we will see few more examples. So students, we will discuss a few examples for the formation of ionic bond. So first example is NaCl. So in these NaCl, always for the formation of ionic bond, as we discussed, it should be a formation of cation and anion. So first cation formation. In the cation formation, we will take sodium. So sodium has electronic configuration 281. So in order to get octet configuration, it loses one electron to form Na plus with 2,8 configuration. So cation is formed here. Then anion formation. So chlorine atom with 287 configuration. In order to get 8 electrons, it takes 1 electron to form Cl minus anion, Cl minus anion, Cl minus anion. So electrostatic force of attraction between Na plus positively charged cation and Cl minus negatively charged anion gives NaCl compound with ionic bond formation. Okay, I think you understood, students. Now we will go for one more example, AlCl3. In this cation formation, we will take a third A group element, aluminium. So aluminium has electronic configuration 1s to 2s to 2p6 and 3s to 3p1. That means outer shell, valence shell has 3 electrons. So it loses 3 electrons to form 8 electrons in the outermost shell. As it loses 3 electrons, it forms aluminium plus 3 cation. Okay, in the anion formation, chlorine takes chlorine with electronic configuration 287, okay, takes 1 electron to form 288 configuration by forming Cl minus ion. But here, see, aluminium loses 3 electrons. So chlorine must take 3 electrons. But one chlorine takes only 1 electron. But aluminium loses 3 electrons. As aluminium loses 3 electrons, that should be transferred to chlorines. Okay, but one chlorine takes only 1 electron. So it is in the need 3 electrons should be taken by 3 electrons. For that, simply we have to do multiply the total equation with 3. Multiply the total equation with 3. So 3 into Cl, 3 Cl. 3 into 1 electron, 3 electrons gives rise to 3 into Cl minus 3 Cl minus. That's all. Okay. Now cation is formed, aluminium plus 3, and 3 anions are formed, 3 Cl minus, and electrostatic force of attraction between aluminium plus 3 and 3 chloride ions forms an ionic compound AlCl3. Okay. And with the help of these two examples, you may practice few other examples like MgO, MgCl2, Na2O, CaCl2, KCl in the same way as cation formation, anion formation, and electrostatic force of attraction between oppositely charged ions leads to ionic compounds like this. You may practice all these examples on your own based on these two examples. Okay, thank you, students. Next we will continue in the part 3.